Hello. In this second part of the product rule, we're going to see some product rule applications, some identifications on where we're using product rule, quotient rule, chain rule as well. And one example of where to use this from a context. So in here we have that Carlos says 22 I love calculus t-shirts today, but sales are dropping at the rate of 3 shirts per day. So what this is saying is we have a function that is in terms of shirts per time, which is days. And notice that the rate of change is also shirts per day. Then here it says he's currently charging $14 per shirt. So this is now a function in terms of the cost, right? But to compensate for doing the sales, he's increasing the price $1 per day. So this is cost, and now this is cost per day. Okay, so it's the rate of change with respect time, which is in terms of day. So it's very easy to see that we're talking about revenue function, right? So we want to see how fast and in what direction the revenue function is changing. So what is the revenue? The revenue is the price times the quantity. And both are functions that depend on time, right? So I can say R is also a function of time. And this is price quantity. Okay, so if I want to see how fast and in what direction his daily revenue is currently changing today, what I need to do is a product rule, right? And we're going to assume that we're talking about today, so this is just R prime is P prime times Q plus P times Q prime. Okay. Notice that we do have those values. So P is the price, and P prime, or the change in P with respect to time, is actually $1, right? $1 per day. And we have P today. That's going to be 22. Sorry, this is the quantity. So this is the quantity today. And we also have the rate of change of the quantity with respect time, which is Q prime, and that's going to be 3 shirts per day. And we actually have the actual price for today, which is 14. Okay, so we have all the information that we need. So this is 1 times 22 plus P, which is 14, times 3. And so this means that, this is minus 3 because it's decreasing, it's dropping. So this is going to be 22 minus 42. And so it's minus $20 per day. How his revenue is currently changing. So it's starting to lose money. Now, so this is one example of one context that we can have for using the product rule. Now, let's go directly to calculating product rules with some functions. So here we have that f of x is x cubed times 3 to the x. So at this point, I'm going to work directly over the formula of the product rule without making any statements of the product rule. So derivative of x cubed is going to be 3x squared times 3 to the x plus x cubed times the derivative of 3 to the x, which is 3 to the x log of 3. Now, for the next function, we have 2 sine of x cosine of x. We can consider this f, we can consider this g, or the first function, the second function. So derivative of 2 sine of x will be 2 cosine of x times cosine of x, which is this one without any derivative, plus 2 sine of x, and then the derivative of cosine, which is minus sine of x. So simplifying this, this will be 2 cosine square of x minus 2 sine square of x. We actually use an identity. This could be 2 sine of 2x, of cosine of 2x. Okay. Now, for the next one, we have that f prime of x is 4x squared times log of x. So I can choose this one as my first function and this one as my second. So f prime will be the derivative of this one, which will be minus 8 x to the minus 3 times log of x plus, and then 4x to the minus 2 times 1 over x, which is the derivative of log of x. So as you can see, a very straightforward product rule. Now here we have a quotient rule, and then this quotient rule, we can do it as a product rule if we just write this to the minus 1. Okay, and so now this will become a product rule with a chain rule. So f prime of x will be the derivative of this, which will be only 3, times square root of x plus 2 to the minus 1. And now for the second one, it will be this one without taking any derivatives, and the derivative of this. The derivative of this is put down the minus, and then to the minus 2, but times the derivative of the inner function, which will be 1 over 2 square root of x plus 0. So this is the general derivative in this scenario. Of course, you can try to simplify a little bit, and at that point you're probably gonna get something similar to what you would get if you do it by quotient rule. Okay, so if you think of this, this can be written as 3 over square root of x plus 2 plus, and then we can see this as minus 1 over 2 square root of x, 3x plus 1 over square root of x plus 2, the square. And so if you multiply by square root of x plus 2 up and down, you get 3 square root of x plus 2 minus 3x plus 1, 2 square root of x, and then everything over square root of x plus 2, the square. Which, if you pay attention, this is just f prime times g. If this is, if I consider this f and this g, or let's say this is h and this is g, then this will be h prime g minus h g prime over g square. So pretty much doing it by the chain rule or doing it by the quotient rule leads to the same place. Now on the next derivatives, we can build in complexity, and we're gonna label this by product rule, chain rule, or quotient rule. So for example, this can be a quotient rule, and if I use quotient rule with f and g, remember it should be f prime times g minus f g prime, everything divided by g squared. So doing that, h prime is the derivative of cosine, which is minus sine, times g, which is x, minus f, which is cosine, times the derivative of g, which is x, so it's 1, over g squared, which is x squared. And that's pretty much the derivative in this. And so we can classify this as a quotient rule. Now, I can do the same thing here with chain rule if needed. So I can also say this is a product rule plus a chain rule, any of the two. Now if I apply the same quotient rule to this one, the derivative of cosine is minus sine times 3 minus x to the 10, then minus cosine, and the derivative of this is minus 10x to the 9 over 3 minus x to the 10 squared. Okay, you can probably simplify this a little bit, but this is a good point to stop as well. Now this one is definitely a quotient rule, but we also have a chain rule because the cosine is composed with something inside. So h prime here is going to be the derivative of this cosine, which is minus sine, but it's minus sine of 4 plus 2 to the x. So I gotta actually multiply by the derivative of the stuff inside, which is going to be 0 plus 2 to the x log of 2. And that's just the derivative of cosine of 4 to the 2x. Now I gotta multiply this by 3 minus x to the 10, and then minus cosine of 4 2 to the x times the derivative of this, which will be minus 10x to the 9, and then divide that by 3 minus x to the 10 squared. Now for the next one, we have a product of the power x to the 5 times sine of x, so f prime will be 5x to the 4 sine of x plus x to the 5 cosine of x, and that's it. This is a very simple one, and this is a very simple product rule. Now this one is a product rule, but combined with a chain rule. So this is product rule plus chain rule. And we have that f prime is 5x to the 4 times sine of 3x to the 4 plus 1, and then now plus x to the 5, and the derivative of sine is cosine 3x to the 4 plus 1, and then multiply by the derivative of the stuff inside, which is 12x to the 3, and that is the derivative of this function. Now C is much more complicated. We have here a product rule with a sum, and the sum has a chain rule, and the product rule also has a chain rule. As you can see, this function pretty much is the same as this. So we already have half of the information that we need. We need f prime, but f prime, the first part of f prime is going to be what we already found. So we can just rewrite that here. I can multiply this, simplifying a bit. This is 12x to the 8. And now I can add the second part, which is corresponding to this. This is going to be 1 over x to the 20 minus x to the 10, because the derivative of log is 1 over the function inside. And then now here I got to do the chain rule, which is the derivative of this. So that will be 20x to the 19 minus 10x to the 9. And that's it. This is the derivative of that. Now a couple more of exercise to finalize this overview. We have here derivative that is not going to have any particular. 3e to the x is just 3e to the x, and 5x is just 5. So we don't have anything special going on in there. This is what we call a basic derivative. Now for this one, we do have a little bit more of complexity. Now we're being multiplied by this square root here. And so that means that g prime is actually going to interact with this. And so we have the derivative of 3 to the e to the x, which is itself, times the square root of x, and now plus, and then 3e to the x, because is the function, times 1 over 2 square root of x. And so that will be just the product rule of this two. But now plus derivative of 5x is just 5. So that's it. And so I'll say this is a product rule plus a sum. Last, one example of a product rule combined with a chain rule. So notice that this is similar to what we have here. So it's going to have a similar structure. It's just not now this square root of x is composed with something else. So g prime of x is still going to be 3e to the x from the derivative of this, and then times square root of 1 plus 2x plus 7x squared, and then plus, and then 3e to the x, because the function without doing any derivatives, and then times 1 over 2, but now it's the square root of whatever is inside, 1 plus 2x plus 7x squared, times, and now we're going to do derivative of the inside function, which is 2 plus 14x. And then now the last part is this plus 5x, which the derivative is going to be 5. So plus 5. And that's it. We can probably try to simplify this a little bit or reorganize it, but that will be the derivative in this scenario. Okay, so with this I have covered most of the day 2 solutions as well. There's some extra problems and word problems that you can check on the key solutions. So make sure to do that. I'll be doing the 3.5 and 3.6 solutions part 3 in class, so I probably won't make a video for that one.